All right, the topic for today is angle measure. So let's go ahead and recall what a ray is, because that's the first thing that we need to know when we're dealing with angle measure. So a ray is part of a line. It has an endpoint and it extends indefinitely in one direction. So taking a look at this figure over here, we see that it has some sort of endpoint or maybe a starting point, however you want to look at it. It starts at Z and then it goes somewhere and it's going to go towards Y, right? And as it goes towards Y, it's going to go towards infinity. It's going to keep on extending, right? So that's what a ray is. It's part of a line. So moving on to the next slide, let's say that you have this particular figure over here, which is what we have right here, and using that same endpoint Z, and then moving to the other direction, to the left side here, right? If I were to connect those two rays, then I will have something like this, right? So it says if you have two rays that have a common endpoint, which is what we have here, we have a common endpoint Z, then and it extends in opposite directions, then what we call this particular thing here, they are known as opposite rays. Okay, that's something that we need to know. So it's a straight line, or basically, let me put it this way: you have two rays, they have common endpoint, they connect, and then it's a straight line, and they're going in opposite directions, right? So those are the characteristics of opposite rays. Oh, I'm sorry, this should not be there. It's an extra slide. All right, let's go ahead and talk about this. Okay, so what if two rays have a common endpoint and don't make a line, right? So let's say that you have this particular ray. We can call this Z, and we can call that, I don't know, Y, right? And it doesn't make a line. What it means, you have something like this, and I don't know, we can call this angle R, or not angle R, point R, right? So we have two rays, one ray here and another ray here, and it has an endpoint or a common endpoint Z. What happens there, the result of having two rays with a common endpoint and they don't make a line, it actually forms an angle, right? So they form an angle. So next thing that I want you to take a look at is this particular thing here. It says the rays are the blank of the angle and the common endpoint is the blank. Okay, so formal things in geometry, there's some terms that we have to know. Of course, we have an angle here, and what these rays are, they are called sides. Right, so if we take a look at this particular angle, this thing, or let me just circle this, this thing is a side, that's side number 1, and over here that's side number 2, okay? And the common endpoint is the vertex, right? You have heard of vertex before in Algebra 1, right? If you have something like a quadratic function, and it looks like this is the vertex. And it's the same thing when it comes to angles, okay? It's the vertex. All right, moving on. Let's go ahead and consider the angle. It says the angle can be named as angle A, angle BAC, angle CAB, or angle 1. Okay, so let me go ahead and give you an explanation. So we have over here an angle which are formed by two different rays with a common endpoint, right? Here's a here is a side, here's a ray, that's 1, and here is another ray, that's a side, that's 2, and they meet at at point A. Okay, they have a common point A. So how do we really name this? This is how we're going to do it. The vertex will be the middle letter, and that is always Always, always, always. So if I'm looking at this, if I want to name this particular angle, I go B, A, because that's my vertex, and then C, right? That's how we write it. So we write angle B, A, C, or you can go the other way as long as that vertex is in the middle. So we have angle C, and then to A, and then to B, which is exactly what we have here. Or you can just call it by the vertex. The point of that is the vertex, which is angle A, or the number that's associated to that vertex, which is angle 1. Okay, hopefully that makes sense. If it doesn't make sense, go ahead and pause, rewind, and then rewatch this part so you understand how to name these angles, because the formality and all the things, the way we communicate math, it's kind of important as you move on in this course. Okay. Let's go ahead and consider the figure right here. So, what do we see? Well, I see that we have opposite rays over here, and then we have some angles being formed. See, so there's an angle here, angle there, angle here. Oh, you can be a little creative and say that this and this, if you have these two rays together, that actually forms an angle, and this actually forms an angle, okay? So that I'm just going a little too quick so that you can see, and then we're going to go a little slow and just name it one by one. So let's go ahead and, number 1 says, name all the angles that have R as the vertex. So what does vertex even mean? So vertex means common endpoint, or common point. So we have R, this is the common point, and angles share that particular point. So remember, when you use the letters, when you use the letters, the vertex has to be in the middle. So you can call this angle, you can go from S to R to P, and R again, it has to be in the middle, so we can call that angle SRP, or you can call this angle PRS, so call that angle PRS, and then we can also call this angle 1, right? So let's just call that angle 1, because that's associated to that point, that common vertex. We're not going to call it angle R. I think it's already implied. Yes, this is, no, actually, disregard what I said. So we have angle SRP, angle PRS, and then angle 1. All right, let's go ahead and move on to the next one. So right here, we have angle P, R, and then Q. So let's write that P, angle P, R, Q. Remember, R is my vertex, so that has to be in the middle when you're writing this stuff, when you're naming it. And the next one, oh, sorry. Let's fix that. Okay. So the next one here is angle Q. R is the common vertex, so the R has to be in the middle when you're writing that. And then P. So I have angle Q, R, and then P. And then we can say angle 2, yes, because it's associated to that. Next thing, we have angle Q, R, T. And then angle T, R, Q. Okay, so we're pretty much done with this, right? Those angles there. But remember, we can see there's actually an angle here too. So how do I name that? I think I'm missing something. I'm supposed to write angle 3 there. Okay, so we can call this angle SRQ. Angle SRQ, or you can call this QRS. And then over here, notice that we can name this particular angle. So that's going to be what? Angle P, R, T, and then angle T, R, P. All right. So I think we have named every single angle associated to R being the vertex there. Let's go ahead and name the sides of angle 1. So let's go ahead and go back. And it says the rays are the sides. So we need to go back to our notes and say, okay, I can definitely do this. I know how to write rays. I know how to write the notation for rays. So let's go ahead and take a look at number 2. It says name the sides of angle 1. Here's angle 1, and I'm looking at the side. So I'm going to go ahead and highlight that. Highlight this angle here. So again, we're taking a look at the rays here. So there is this ray. How do I name this ray? So I need to start at the end of the vertex, the end point. So I have to write R. And then where is it going? It's going in the S direction. It's going to S and then going to infinity. So I write S at the end there. And then what do I put above? Well, I have to put a ray. So it's going to be a little line with just one endpoint. Note, not 2, just 1. So that's how you name that particular side. Now we got to take a look at this particular side over here, right? So where does this start off, or what's my end point? It's angle, it's point R, so I have to write R. And then where is it going? It's going to go to P and then to infinity, right? So it's going from here to here, so that's that P. So all right, P. And then what do you put above? You're going to put a little line with an end point. Okay. Hopefully it's making sense over here. Let's go ahead and move on to the next slide. If I'm going too fast, make sure that you pause and then rewind and just rewatch the parts that you're a little confused about. Okay, let's go ahead and consider this figure. It says name the vertex of angle 4. So again, we're just going back to naming things. So let's name the vertex of angle 4. Again, the vertex is just the common endpoint, right? So this is the common endpoint. And I'm looking at 4. Okay, where is 4? 4 is right here. And what is it associated? What vertex is it associated to? It's associated with B. So all I gotta write is just B. Okay, that's the point B. Name the sides of angle DBC. So we're going to go from in order, right? B in the middle, and it's in the middle, so that means that's my vertex. So let's take a look. We have D to B to C. Okay. So if it says name the sides, that means I got to deal with the ray. So I know that here is the common endpoint, and one of my sides is here, and my other side is there. Okay. So looking at this particular ray, let's name it. So I have to start with my common vertex, or common point, which is B. Where is it going? It's going to go, let's say, to D, all right? To infinity. So this is what I'm going to write, B, D. Sorry, I think I made a mistake. B, D, C. No. I think I'm fine. So it's going to be BD. And then the next thing, I'm going to start off with B to C. All right, that's my next thing. So I write BC with a line above it. Only with one arrow. Okay, moving on. Write another name for angle DBC. So if I'm looking at this, so here's D, B, C. And then we know that B is my common vertex. What is the number associated to that particular vertex? Well, it's just 3. Sorry, not 3, just angle 3, okay? So write another name for angle DBC. You just call it angle 3, and there you go. Okay, so let's go ahead and move on to something that we already know. We should know what a right angle is, what an acute angle is, and an obtuse angle. A right angle is an angle whose measure is 90 degrees, right? So when you have something like this, And then there's like that weird square. That is what you call a right angle. It's 90 degrees, okay? So it's a 90-degree angle, and that's pretty much it. And an acute angle has a measure less than 90 degrees. Well, I take this, and I'm going to shrink it a little bit. I'm going to shrink the angle, and it's going to look something like that. And lastly, we have an obtuse angle that has a measure greater than 90 but less than 180. So it's going to be, of course, it's going to be bigger than these two, but less than 180. So 180 looks like this, but I need to shrink it a little bit to make it less than 180 degrees. So it would look something like that, right? And we know that obtuse, that's usually, when we think of obtuse, we think about the bigger angle, right? But it has to be less than 180 degrees. Okay, so that's all I have for that. Now I gotta move on to something called congruent angles. Now, we've already talked about congruent segments, right? So if I have this segment here and this segment here, and let's say that this segment, the measure of this segment is 9, and this measure of this segment is 9. These are two different segments, but the thing is they have the same measure. They have the same sort of distance, right? And if I'm going to show the reader, hey, I'm going to say that this right here is congruent to this particular segment here, I got to use what we call tick marks, right? These tick marks are going to help me, or is going to show that these are congruent. Now, in the case of angles, we use something called arcs. So these things right here, those are arcs. And those are going to, when it comes to angles, those are going to show us what's congruent. So let's take a look at this figure over here. I can see that angle ABC, or the measure angle of ABC is 65, and the measure angle of DEF, that's 65. Well, they use one arc here to indicate that those are congruent. So I will write the measure angle of ABC is congruent. Remember, congruent, this is the congruent sign over here, to measure angle DEF, because they both have the same measure. Now, why am I writing measure, the M, instead of just saying ABC, angle ABC, or an angle DEF? Well, when there's a number involved, when you're calculating, or when you're trying to figure out how long something is, you write measure. If you're just naming things, you don't write the M. So I'm just going to point that out there, because that's kind of useful when we're going to get into something like very difficult later in the semester. Okay, so that's that. Now, tell me what else is congruent. Well, I can see that this angle and this angle, they're congruent, because I can tell by these arcs over here. Now, notice that these have two arcs instead of one. If I write one arc here, you're going to say that that's 65 degrees, which is not the case. Obviously, this angle compared to this angle, they are different. So we use different arcs, number of arcs, to differentiate some stuff here. So let's go ahead and write some things down. Okay. So we can say that angle CB to E, or F, I guess, I don't know. Yeah, CBE, and let's say angle DEB, they are congruent. Sorry for the long pause. I'm trying to look at my notes to see if I'm doing things right. Yeah, so those are congruent. And notice that I'm not writing measure, right? I'm not writing measure because there's no number involved or how long that is. So that we can say that measure C, sorry, not measure. I just literally told you not to do that. Angle CBE is congruent to angle DEB. Okay, so this is my answer, and the thing over here is my answer there. All right, let's go ahead and talk about angle addition postulate. It says that the angle addition postulate says D is the interior of angle ABC if and only if the measure angle of ABD plus the measure angle DBC is equal to the measure angle of ABC. So take a look at the diagram over here. Okay, so where's measure angle ABD? It's right here. That's the measure angle ABD. Now where's the measure angle DBC? DBC. So if you add these two angles together, you're going to get the whole thing, which is measure angle ABC, right? So that's the whole idea of that part plus part is equal to whole. So this is my part, this is my other part, and if you add them all together, you're going to get the whole thing, right? So let's take a note of this because we're going to move on to something over here. So let's take a look at number one. It says if measure angle NKL is equal to 67. All right, so where's NKL? NKL is right here. So we can say that this thing is 67 degrees. Let's just write 67 degrees. And then the measure angle of LKM, so LKM is right here. So, I will write 38 degrees. And the next thing I want to go ahead and figure out is the measure angle NKM. So, NKM is right here. So, what is that trying to say? That's trying to say that the part plus part is going to give me this whole thing over here. So, let's just write that down. So, I have measure angle NKL plus the measure angle LKM is equal to the measure angle NKM. And I'm going to start substituting things. So I know that NKL is 67, and I know that LKM is 38, and that's going to help me figure out what NKM is. So if I put it in the calculator or do the math in my head, that's going to tell me what angle NKM is. And so that's going to be 105. So the answer is measure angle NKM is equal to 105 degrees. And that's my answer. Next thing I need to figure out is this. It says if measure angle NKL is equal to 9y plus 15, and the measure of LKM is 5y plus 2, then we know, and then the measure angle NKM is equal to 115. So let's go ahead and take a look at let's go ahead and take a look at the figure over here. So we know that NKL, which is 9y plus 15, and then angle LKM, measure angle LKM is 5y plus 2. So that whole thing here is 115. So measure angle NKL plus, so this is part of that angle, plus measure angle LKM is equal to this whole thing here, right? Again, if you're confused about this, you can think of this as like the chocolate bar example that I told you about, right? So if you have a part of a chocolate bar and plus part of the same chocolate bar, that's going to equal the original chocolate bar, the original height or the length of the chocolate bar, right? So here's the part plus part is going to equal to the whole thing, which logically makes sense. Start plugging things in. So we know that NKL is 9y plus 15, and we know that LKM is 5y plus 2, and then the whole thing is 115, which is NKM, right? Sorry, I need to write this. I'm going to put measure angle NKM. And then all I got to do is I need to combine the like terms. So I have 14y plus 17, which is equal to 115. And then if I subtract both sides by 17, I get 14y, which is equal to 98. Divide both sides by 14, I'm going to get y equals 7. But you're not done yet, because it says find the measure angle LKM. So where's LKM? We know that measure angle LKM is 5y plus 2, right? So if I know that y is equal to 7, then what do I do with this? Well, I'm going to replace this y with that 7. So I have measure angle LKM, which is equal to 5y plus 2. Then I replace this y with this number, 7. So I have 5 times 7 plus 2. If I put that in the calculator or do the math in my head, I get 37 degrees. That's my answer. Okay? So take a moment, review what's going on, and yeah, let's go ahead and start moving on to the next thing. It says a ray that divides an angle into two congruent angles is called an angle bisector. So let's take a look at the figure below. It says the measure MPR has an angle bisector. Yes, that does. So here's my original angle. So this is M, P, and then R. If I have this angle bisector, which is this over here, if I have this angle bisector, which we'll call PN, then it's going to create two angles, right? Here's an angle, and here's another angle. And we know by the prefix bi, it means two, and if you have a bisector, it's going to cut that section in half into two congruent angles. So this angle right here is congruent to this angle right there, right? So these angles, so I will write angle MPN is congruent to let's say R angle RPN. Remember, the P is the vertex. Has to be in the middle, right? So MPN is congruent to RPN. And it's this thing, when it comes to the bisector, cuts the original angle in half. Cuts in half. All right, so let's go ahead and start practicing with angle bisector. So it says in the figure to the right, ray QP and ray QR are opposite rays. And we know that ray QS bisects angle PQT. So we know that QP and then QR, they are opposite rays. And angle PRT has an angle bisector, and that is a ray QS. So what does that mean when you have a bisector? It cuts that original angle, so this is the original angle, into two different angles, which both angles are congruent. So let's take a look at number one. It says if measure angle PQT is 60, so let's start labeling that right now. PQT is right here. That's going to be 60. And measure angle PQS is 4x plus 14. So here's PQS, and that's 4x plus 14. Well, I know that this is the bisector, right? This bisects the original angle. So if this thing is 4x plus 14, which is one of the angles that was created from this particular bisector, then what is this supposed to be? Well, that's going to be the same thing. That's going to be 4x plus 14. So this is a part, that's going to give you this whole thing here. So let's just plug it in. I get 4x plus 14 plus 4x plus 14, which is equal to that whole thing there, right? This whole thing there. So combining like terms, you should have 8x plus 28, which is equal to 60. If I subtract both sides by 28, I get 8x equals 32. And 8x equals 32. That means I got to divide both sides by 8. That's going to give you x is equal to 4, right? And that's just me finding x, and I don't have to do anything else, so I am good there. Alrighty, so let's go ahead and do the next problem. It says if measure angle PQS is 3x plus 13. So where's PQS? PQS is right here. So angle PQS, that's 3x plus 13. And then measure angle SQT. SQT is right here. Angle SQT, that's 6x minus 2. And then this whole thing here is measure angle PQT. Okay, let's go ahead and just set up the problem that we've done before, right? We have 3x plus 13 plus 6x minus 2, which is equal to this whole thing here, which is measure angle PQT. Okay, so you do the regular thing. You're going to combine like terms, and you get 9x plus 11, which is equal to measure angle PQT. Okay? So now, you're probably confused, right? What the heck? You can't do anything on the other side. If I subtract both sides by 11, well, you can't subtract anything here. So, what I have to do, it's a good thing that you write or you label the parts of your angle, because number one, that's super useful. Number two, the thing that I want you to remember is that you have an angle bisector, right? And this is our angle bisector. It's bisecting this little angle here, and it has variables. It has constants there. We know that because you have an angle bisector, it cuts this original angle in half. Therefore, this angle is congruent to this angle. And what can I say about that? You can set those things equal to each other. So you have 3x plus 13, and then you equal that to 6x minus 2. And then you can go ahead and start combining like terms. You will get, let's say, 3x is equal to 15, therefore x is equal to 5, right? You figured out what x equal to, right? And we know that a part plus part is equal to the whole thing here. Notice that I have 3x plus 13, and then if I combine that with my other part, 6x minus 2, I can get that whole thing there. So if x is equal to 5, all I got to do is I start plugging it in. So 3 times 5 plus 13, which is my part, plus I have 6 times 5 minus 2, which is my other part. If I figure this whole thing out here, if I put this in the calculator or do it in my head, I'm going to get 56, which is my whole thing. Okay? So what I did from the start to the end is I'm just trying to figure out my steps. I'm trying to put it. This is a little tricky. I know it was a little tricky at first, but if you start labeling things and just think about it a little bit, knowing your definitions, you'll be able to do this problem without any worries. It will take long, but it's actually pretty straightforward if you just put a little thought into it. Okay, so that'll be all. Hopefully this makes sense. If you have any questions, again, shoot me a message and I will help you with anything you need. Toodles!